MySQL provides two unique types that work from lists of strings. So let's learn about them using the Scratch database. I'm going to start by creating a table. And of course, I will drop table if exists. And we'll call it test. Create table test. We'll have an ID column and an enum column. So enum works from a list of strings, and the column can hold in each row one of the strings in the list. And so I'll give it a list of strings here: Pablo, Henri, and Jackson, and no comma after that last column in the definition. And so we can insert into test values. And so I can put Pablo, Henri, or Jackson, but no other string is valid in this column. And then we'll select star from test and press go. So here we have 3 rows, and column A is Pablo, Henri, and Jackson. Now what's interesting here, what's actually being stored, because we could have a lot of columns. We could do this again. We could just copy and paste these 3 again, and I now have 6 rows, right? I can have these same values many times throughout them. And I don't need to store these strings over and over again. In fact, all that this column is storing is numbers. If instead of Pablo here, I put in a 1, and instead of Henri, I put in a 2, and instead of Jackson, I put in a 3, the result is the same. Because really all that's being stored in the enum column is an index into this table of strings. So I could have a bunch of these, and I could have 4, 5, 6, 7, and each of these rows in that column is just holding a number that represents an index into that list of strings. So it's a space-saving tool, and it's also a bit of a constraint tool because you're only going to have the values that you've defined in the table. So that's enum. Set works very similarly, and I'm just going to change this to set, and we'll use exactly the same. We just have Pablo, Henri, and Jackson, and I'm going to say go, and it looks like our result is exactly the same, but there's a very distinct difference. I'm going to copy this and put a few more of them here, and I can have Pablo and Jackson in the same row in that one column. I can have Henri and Jackson, or I can have Pablo, Henri, and Jackson. And you can see in these rows down here, we have more than one value from the list. So the distinction here is, rather than how enum works, where each of these rows for this column holds a number that represents an index into this string, instead with set, each bit in this value represents one of these strings. So if I come down here, I'm going to take this one and I'm going to copy and paste it 3 more times, and I'm going to put in the value 1, and I'm going to put in the value 2, and now I'm going to put in the value 3, and actually let's keep going, 4, 5, 6, and 7. Because you'll notice we have 3 strings defined. So 3 bits are actually being defined here. And there are 7 possible values with 3 bits. And so I'm going to say go here. And what we have is a 1 is Pablo, 2 is Henri, 3 is both of those first 2 bits set. And so that's Pablo and Henri. 4 is just that 3rd bit set, and that's Jackson. 5, the first and the 3rd bit. 6, the 2nd and the 3rd bit, and 7, all 3 bits are set. So each bit represents one of these strings. That's the distinction between set and enum. So if you know you're going to have a limited number of possible values in a column, it can be much more economical to store an index, as in an enum, than many copies of the same strings. Likewise, if you need to store more than one from a set of possible values, a set can be economical as well. And a set may also be useful for storing flags and state indicators.